We first saw circular motion back in Unit 3 when we were doing the calculus unit. So let's take a brief review of what uniform circular motion is. So remember, if we look at uniform circular motion, we're saying that we have something that's moving around in a circle. We know that the velocity, so if our particle is here, we know that our velocity is tangent to the circle, and we know that our acceleration, let's try and draw this better, is going to be pointed inward toward the radius, toward the center of the circle. So if the circle has radius r, we recall that we said that the acceleration, the magnitude of the acceleration, a, is v squared over r, so that a is minus v squared over r in the r hat direction, right? So the magnitude of v squared divided by r, but we're pointing radially inward. So in the case shown here, a would be minus v squared over r x hat. If we're on the other side, of course, velocity is down, the acceleration is inward, and here it would be positive v squared over r x hat, right? And then we also said that the velocity, if it's uniform circular motion, again, the velocity is just 2 pi times the radius, right? Because that's the total distance around the circle divided by the period, the time that it takes to make one complete revolution. And so this is the basics of uniform circular motion. And for the most part, this is all you'll really need for this unit. Your book goes a little bit into non-uniform circular motion, and I think that's it's important for you to see. But there aren't really enough questions on that I'm going to put those on the exam. So feel free to look at those in your book because it could be beneficial to you. But don't expect me to be actually testing you on any of that material.